Good morning, everybody. We're back with our second day at looking at language integrated query or LINQ. And one of the things that I've done with my repository is I downloaded that diagram from the place where I got the Westwind database. And I put that into my repository just so I can reference it. So I've got it open here in Visual Studio Code. And when you're going and writing LINQ, even though you're writing C#, if you're using query syntax, it looks a lot like SQL. But by looking at the ERD, you can understand or interpret the ERD as representing what is the C# model or set of classes that represents all of the tables. So we've got these navigation properties between the tables based upon the relationships. And we can turn around and think of each of these lines as basically representing two different navigation properties, and they're intended to have a particular cardinality. So there's a quantitative relationship between them, and that's what helps us to determine whether we are dealing with one of something or a collection of something. When we looked at employees who have 7 or more territories, we recognize that each employee has potentially many employee territories, but each employee territory will be managed by or belong to a single employee. So that basically winds up having some characteristics. So when I think of the employee territories entity or the class that models this table, it will have a navigation property, perhaps called something like employee. And that is representing the fact that the employee territory connects to or relates to a single employee. In contrast to that, if I look at the employees, because it relates to a collection, to multiple employee territories, one of the navigation properties I'm going to see on the employees is probably something that looks like employee territories. And you should note the fact that we're dealing with a plural here. So examining an ERD can be really helpful in understanding the nature of the navigation properties that we wind up having, particularly the nature in terms of there being many versus there being a single item. Whenever you have many of something, you can effectively query that. You can query the collection. When we think of language integrated queries, they are querying collections from from person in employees. So the employees representing the table is a collection. And then if I did the employee, the person, each person, the individual instance of it, dot employee territories, that's many employee territories. So I could even do a little bit of query search of that. So think for a moment now about this interesting relationship that we have here. What does this foreign key relationship imply? Anybody want to venture some thoughts about that? You can type them out in the chat. One employee reports to many. Yep. One employee can report to multiple managers. No, not quite. Graham's is a little bit closer to that. An employee is able to report to another employee. That's right. Now remember, relationships go two ways. So every one of our relationship lines represents two different kinds of relationships. When I think of the employees to the employee territories, it's the employees to the employee territories, and then it's the employee territories to the single employee. So we can write out two sentences for this, for these relationships. So let me go ahead and do a little bit of a sentence for the relationship between these two. I'll have a couple of sentences. And I'll say each employee territory must be managed by one and only one employee. So that's my sentence. So notice there are many employee territories. So this is a database table. But when I think of the information that's in here, I can be thinking of one row. If I were to look at one row of information from the employee territories, I could say of that one row, that employee territory has to be managed by one and only one employee. When I go and look at it from the perspective of the employees, I'll go and I'll say each employee, and I'm going to change this just a little bit. I'll say may be responsible for one or more employee territories. Now, if you had the good fortune to have taken SQL from me, I would have taught you a pattern to translate any ERD diagram into English. And the pattern basically goes about identifying a choice between must be and may be, or the minimal for the minimum cardinality, So I'll put in here the minimal cardinality, and the one and only one versus the one or more describes what would effectively be the maximum cardinality. Now, this particular ERD only shows maximums. So I'm actually making a little bit of an interpretation when I make my choices between my minimal cardinalities. But must be would be indicated on a line. Let me get my colors so that they're going correct. So if I had a relationship line, a must be would be a vertical bar on that. Whereas a maybe on the cardinality would be the 0. Oh, I cannot draw very well freehand with this. Pretend that's a 0. Alternatively, when I'm looking at the maximum cardinality and I think of one and only one, that's the notion of the vertical bar here again. The one or more has a notion of the crow's feet. That's what the crow's feet mean. So, however, the left one connects, the leftmost entity connects to the rightmost entity, or the first entity connects to the second entity. So that connection to that second entity is what determines it. So here is where I am getting the relationship for the maximum cardinality, and if I had both cardinalities on here, it would be just to the immediate left where I would have the minimum cardinalities. Cardinality, by the way, is just a term that imply, or that describes a quantitative relationship. That's what the term cardinality means. So let's return to our question of the employees and this particular relationship line. How would I turn around and describe that? Well, the foreign key, you'll note, has been named reports to. So that's kind of a helpful phrase. You'll notice that the phrases I have, managed by and responsible for, those are prepositional phrases. You can tell by the preposition by, for, to. So that's a good one. I can use that for part of that relationship. So when I say reports to, that reports to, and I follow the line along, and I see it's to a single employee. So I can say, for one of the sentences here, I can say that each employee, and I'll say must be, and rather than reports to, I'll say reporting to, must be reporting to one and only one employee. We can think of that particular employee there as being, as it were, the manager of the employee in question. Going to the other sentence, I could turn around and say each employee, and I'll say may be responsible for managing one or more employees. So that's this part right here. Each employee may be responsible for managing one or more employees, the crow's feet, one or more. So that self-referencing foreign key relationship helps me to see an important piece of information about how the data is being structured in the database. Being able to read your entity relationship diagram makes a big difference to understand how all the data is related to each other. And it can be a guide for you to understand how those database tables are being modeled in C# by a whole bunch of different classes. When we used LinkPad to connect to a particular database, LinkPad automatically went through all of those database tables and created the classes for us and created them with navigation properties so that we can go and query stuff from the entire database. Okay, with that in question. And one last thing that I'm going to make a note about what LinkPad does in terms of those navigation properties is it has to guess at the name of the navigation property. So there is nothing on these lines that actually give a name for what that navigation property should be. So it typically goes and uses it kind of guesses out a name for the navigation property. And you can see the singular versus the plural there. Sometimes the guessing of the names is not entirely what we may choose for ourselves. So we can always rename our navigation properties to be whatever makes better sense. So for example, manager would be a really good name for a navigation property on this relationship here. Okay, let me take a little bit of a screenshot and throw that into the chat. So yes, an employee is able to report to another employee because they can report to a single manager. And one employee can not report to multiple managers, but is responsible for looking after multiple employees. Let's take a look at a couple of the link queries that we have within our samples, and we'll open those up in LinkPad. We'll start with this particular question. List all the employees who do not have a manager. So I could say, and I better turn on this thing to say use SQL Server Westwind. So the previous copies that I have of those particular link queries was using a link to SQL, but I'm using the entity framework connection right now. You can tell that distinction right there, that there is an entity framework distinction versus this one here, which is a link to SQL. But to express that, I can say from person in employees, where the person reports to employee. So that was the name, the navigation property name that was generated by LinkPad. Which employee they report to. Notice that it's in the singular. If that person reports to employee is null, then and that reports to employee if that's the manager. So that's what I would have rather than reports to employee. That's where I would have gone and perhaps used the navigation property name manager. Person and employees where the person's manager is null, then if there's nobody managing this person, they must be, they don't have a manager. In fact, that's probably going to be, what would you call the person at a business who doesn't report to anybody? What would you call them? Yeah, the boss, maybe even the big boss or the CEO or something like that. So that's who we're looking for. So that's the filtering that's going on. Right now I'm focusing on that whole notion of filtering out. So I only get certain people out of the employees table. Now, what do I want to say about those people? Well, I want to get a few pieces of information. Here I decided to get their full name by turning around and concatenating their first and last name with a space in between. And I wanted to get their job title. So that was job title, just like first name and last name are columns in the employees table, and so they're properties on the employee class. For the age, I decided to do a rough calculation of their age by taking the current date and time and subtracting the person's birth date, and then with the difference between those two dates, getting the days component. How many days are between now and when the person was born? Divide that by 365 for a rough estimate, ignoring the leap years, a rough estimate of how old they are. And because it's going to be integer division, an int divided by an int, I'll get an integer result. I'll roughly get their age, their current age. There's another cool little one in here. LinkPad has an interesting thing that you can do with byte arrays that represent pictures. They have an extension method called toImage. So I'm going to be able to see a picture of who this employee is. And then I get also the person's address. By the way, note as well that this here is a navigation property. That's a navigation property to the address entity because each person has a single address. The foreign key is address ID, but address itself is an instance of that address entity. By the way, what I've gone and done here in terms of marking up this particular or drawing on top of this particular link query, what I've done can also be done or written as comments inside your code. So as you're going through all these link examples, it can be worthwhile to add your own comment lines to describe the different pieces. Well, let's run this. And to image and no accessible extension method of to image exists. Oh my goodness, did they change what we have for there? Let's see, dot to, or is there image? Looks like yours worked. Okay, if yours worked, it's probably because you're not using the SQL Server Westwind, you're using this one. So if I change that to use Westwind, then I know it will work. Then it'll work fine. And in case you're wondering why is that the case, notice that there are here two different kinds of connections in LinkPad. So this particular connection here uses what is called link to SQL. That was one of the first things that came out. Whereas this one here, you can see the EF, that is using link to entity framework. So that's the distinction that we need to make between those two particular kinds of items in our connection. The link to SQL I knew had the extension method toImage, but I guess they don't have that in the link to entity framework. So that's interesting. I thought that would have continued on. You only have link to entity framework? Did you get the image? Do a quick little copy of that. It works on linked entity framework? Okay, then why didn't mine work? Let's try that again. Oh, mine didn't work. .NET Auto 5.1, blah, 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 blah. Weird, yeah. You know what? I should just do a quick little check for updates. Da, 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 da. No, it says I've got the latest release. Although it's saying LinkPad 6 beta, which I think should be out of beta. So maybe I have the latest beta, but not the latest public release. I'll have to double check, see why that is. Okay, okay. I know I'm going off on a rabbit trail, but I got to check this out. Link pad EF to image extension. Missing. If core driver for SQLite. I'm not doing SQLite. I'm doing SQL. The include extension method may not be there as well. Oh well, I'll have to come back to that. Look at why I've got that. For now, I'll go back and I'll switch back to Westwind so I can get the image. I'll do the same thing for the next one as well. So, anyways, Andrew Fuller is the big boss out of Westwind, and this is his address. So remember, I said address was a navigation property. It points to an instance from the addresses table, a row of data from the addresses table. So it's got all that information in it. Questions or comments?
Just wondering if LinkPad actually needs the relation. I forgot what was it called, like ordinality. Is one employee can have can report to multiple employees, but their employees report to none. So it'd be a zero to many relation in the ERD. So I'm trying to think if the relation the other way is required or not.
So a one to many. We wouldn't say a zero to many, but we would say a one to many. Anyways, because it has a relationship to itself, there will be two navigation properties on the employees table. One of them will they've called reports to employee, which is the manager. And then the other one, if we look at actually what I'll do is I'll just temporarily throw in a person dot oh, there should be another one in there. Let me see. Let me check this side here, see if it generated it right. So it's got reports. Here it is right here. Let me scroll this down so I can get the full thing for the employees. So notice the reports to employee. The reports to employee goes to a single item. So so that is this one right here, reports to employee. And then the other one is reports to children, is what it says. Notice that it's got a green color and it goes to a crow's foot. So that's the whole notion that there are many children or many employees that they can look after. So if I was doing this myself, I probably would have named this thing, that particular navigation property, as subordinates. And then I would have named this particular one to be manager. So that's how I would have done that. In fact, that's worth a little screenshot as well. Okay, let's take a look at the example number 6, because that does go to the other direction. List all the employees who do not manage anybody. Oh, wait a minute. List all the employees who do not have a manager. So that's the boss. List all the employees who do not manage anybody. If you don't manage anybody in the organization, then you're just a regular worker. You're kind of on the bottom tier in the organizational chart. Now, I mentioned that reports to children here, that is a collection. In fact, one of the nice things about having the paid version of LinkPad, when you hover over things, you can see the data type of it. So reports to children is an entity set of employees. So that is effectively a collection. Yes, those names, reports to employee, reports to children, were automatically generated when there was the reverse engineering of those particular of that particular database. We're going to go through, I'll show you the reverse engineering process to generate all of the C# classes from a database. Last term, you guys typed out those classes yourself, but you can just automatically generate all of them, and you'll get the navigation properties as well, and then we can turn around and rename them to something better. But beyond that, what I want to kind of point out here is, as we are looking at these navigation properties, we need to discern whether we're talking about a collection or an individual instance. Reports to children is a collection, which is why I can go ahead and use an aggregate property on there, or I can use the property count. Count is a property off of the entity set of T. So in other words, what I'm effectively saying is, since the reports to children is a collection, I can find out how many there are. If they have a count of 0, if they're reports to children, if the number of people reporting to this particular person is 0, then they're on the bottom of the totem pole. They don't manage anybody. They're not looking after anybody at all. And so for this one, I'm also getting the person's name, the job title, and their picture. So who's in the middle of all of this? Or sorry, not the middle. Who's at the very end of the organizational chart? Who are all those people? And by the way, let me do another screenshot, because screenshots are so helpful. So when I look at this and I run it, it turns out that Nancy, Janet, Margaret, Michael, Robert King, Laura, Anne, all of those people are just regular sales representatives. They're at the bottom of the totem pole in this particular organization. He's been there probably the longest, which is why he's not smiling. He's the only guy that's not smiling, Robert King. Been passed over for promotions over and over again. Not a happy camper. So that's interesting. We've been looking at the employees without a manager. That's the big boss. He does, doesn't he? Um, and then we've been looking at the people who are just like the frontline people. They don't manage anybody. They just do frontline sales representative stuff. Let's look at this next one, because there's actually a third group of people, and that is employees. List all the employees who are managers. And what we'll do is as we do that, we'll give the name and their job title and their picture, and then we'll find out who are they looking after. Who are the people that they're managing? Notice something here as well, and I'll get back to this in a bit. But notice I have a link query, a subquery inside of my main query. So that's helpful to note. But let's look at the results. So here's our Andrew Fuller guy again. Remember, he was the big boss. Nobody reported to him. Who does he look after? He directly manages Nancy, Janet, Margaret, Stephen, and Laura. Who's the other manager? Stephen Buchanan. He's a sales manager. He looks after Michael, Robert, and Anne. Notice that Stephen himself is being managed by Andrew. So Stephen is the middle manager in this organization. So that's kind of a helpful piece of information to discover. For all we know, in this particular company, it could be that Andrew, a number of years ago, as the company was growing, he made a decision and said, you know what, it's too hard to manage more than five employees. So maybe he turned around and made a rule for his business. Every manager can only have a maximum of 5 employees that they look after, and everybody except the top guy has to report to somebody. So he went and decided, okay, Steve, you're the guy that I'll promote to a manager, and you can look after Michael, Robert, and Anne. That's why Steve is smiling and Robert has that sad face. Robert was passed over. Not a happy camper. Okay, let's take a little closer look at this particular query. So this time when I did the check, the person reports to children. Remember, that is a entity set of employee. There's a whole bunch of them. When I checked the count, I looked for a count that was greater than 0. That gets me people who are looking after more than 0 people. That means they're looking after somebody. And when I get their information, the reports to children, remember, that is a collection. So I said that reports to children is a collection. Because it is a collection, I can query it. So when I look at the person's children or subordinates, I can query that. And then as I look at each one of those, I'll just grab their first and their last name. Now, if I query a collection, what I get back is another kind of collection. In fact, it's helpful for me to look over this, subordinates, and note the fact that what I've got here is an IEnumerable of some anonymous type, but it's an IEnumerable. So that means subordinates itself is a collection. Now, you're probably hearing me use these terms like collection, and then I get into specific types like IEnumerable or the entity set. It's interesting to note that that when it references some of these, you get some things such as IEnumerable. That's an interface. An entity set is a generic collection. Um, but all of those particular items will have will probably have some kind of inheritance or interface implementations, but it all falls under these notions of classes that represent a whole bunch of data. We call those collections. If you remember using statements in your C# files from before, you may have seen using system.collections or using system.collections.generics. So those namespaces had classes for representing a whole bunch of items. And an array, by the way, is another type of collection. That's kind of a raw type of a collection. But the whole idea, once again, is that if you have a collection, you can query it. So if I query from a collection, if I query a collection, the result is a collection. Let me show you once again. I queried from the collection of employees, and so I got back a collection that happened to have 2 items in it. That was true as well with this employees without a manager. When I went and ran this, I got back a collection that happened to only have had 1 item in it. When you query a collection, you get a collection as a result. And since the reports to children is a collection, if I query that collection, I get a collection back. 5 items, 3 items. Questions or comments? Okay, here's what I want you to do for the next little bit. So we're going to take about a 20-minute break. What I want you to do, I've given you a few different images here, like this one, for example. The images that I've given you in the chat, I want you to turn around and download them. Put them into your workbook. Maybe make a page in your My Notes folder called link.md and start referencing those images so that you'll be able to make some notes about this after class. Because I want you to have that bit of a connection. So I'll give you some class time to work on that. I'll give you about 10 minutes to get those downloaded and to at least get the Markdown file started in your documentation. Do a commit of that, push it up to the cloud. I've been checking everybody's workbook repositories. I see that there's a little over half a dozen of you that have put up your sketch image of the better customer order system or application. And so those have been looking pretty good in general. But try to keep the information up to date in your workbook, because that's, if you do that while things are fresh in your mind, then that really just improves your whole learning process. So with that being said, I'll put up a timer and we'll come back after that time and take a look at things. See you in a bit. Well, we're back from our break. I want to move on to a couple of other examples of some queries. And we're going to take a little look at solving this particular problem. List all the customers and the name, quantity, unit price, and subtotal of each of the items that they've purchased. And I'm going to just reorganize my my item that I have here, my ERD, and I will have to shrink it down just a little bit more to fit everything that I want onto there. There. So back to our particular problem that we're going to look at, and noting one of the important reasons that we turn around and use language integrated query. We want to find out here all of the customers, and we want to know the name, quantity, and unit price and subtotal of each of the items that they have purchased. So when it says we want to list all the customers, it doesn't exactly specify what it is we want out of our particular customers. But let's just assume for the moment that we want to be able to get the company name of the customer. And then the next thing that we want to get is the name, quantity, unit price, and subtotal of each of the items that they've purchased. Well, we see that customers has a relationship to the orders, and orders has a relationship to order details. So it's here within order details that we're going to get most of the information we need. Order details itself has a relationship to products. Let's look at it in terms of its cardinality. So each customer has many orders, and each one of those orders can involve many order details, which are the line items. And each order detail is for a single product. So when we talk about wanting to know information about the items that they've purchased, what we're interested in knowing are the name, the quantity, the unit price, and subtotal of each of the items that they've purchased. So the name is here in the product information. The quantity is here. The unit price is here. The subtotal is going to have to be calculated. When we go and are looking at the data in our database, understanding how they relate makes a big difference. So we're going to be starting everything from the customers table as we try to go and get all of the details, which is this stuff here, the product name, unit price, quantity, and the subtotal. So use your entity relationship diagram to understand the kind of object graph that you have. And as I mentioned before, we see why we're using link in the first place. The shape of the data that we want to get out looks different than the shape of the data as we store it inside of our database. So our database here shows everything in a normalized fashion. And when we're looking to pull information out, we are effectively denormalizing it. And that's what we're doing in our link. So let's look at our actual query that I have for this one. So from the data in customers, so customers is like a collection of customer, so it's like an array. Data means it's the single customer. If you've got a collection of X, a whole bunch of X, then this part here is a single X item. So from data and customers, that means data is a customer object and it has the company name property, which we get. And data has a whole bunch of orders. So what comes back? What is purchase? What's the data type of purchase? Purchase is an order. Each order, that is each purchase, can have many order details. So that's a collection, which means that my line item is an order detail object. And from that order detail object, I can go through to the product and get the product's name. For that order detail, I can get the quantity of the items, the unit price, and I'll do a simple little calculation of a subtotal, unit price times quantity. Let's take a moment to look at the result. Oh, by the way, I had this order detail highlighted. If you highlight a single item in LinkPad and you press F5, it'll only run that particular highlighted portion. That's a lot like SQL Server Management Studio, by the way. But I want to run the whole thing, so I'll make sure nothing's highlighted. Then I'll press F5. And now I'll get my collection. Let me go and format that to one nesting level. Yeah. So I can effectively see that this company had 12 items, this company 10, this company 17, Around the Horn had 34 items. This one had 52 items. So it had 52 items in the sales. Sales itself is a collection. And I can see the details of what's inside of those. Now I see a bit of repetition because the queso cabrales on is of where they purchased 24, that was on one particular order. This one was on a different order. So I've got, I'm getting the line items for each of the orders. But nonetheless, I get a nice little bit of a summary because when when they ordered the queso cabrales on this one purchase order, they bought them at $16.80 per unit. But when they purchased them later on at on another order, they paid $21 per unit. So there's a price increase. This is how we can get kind of useful, rich information out of the database that we can use to maybe create reports or do all sorts of other things like that. Key to a lot of this, and the reason for my throwing in comments like these, is because I want to appreciate the data types of the things that I'm working with. So being able to see beneath the surface of the code to the data types that I'm dealing with is essential to being able to reason about what I'm trying to accomplish. So if you have been really focused on primitive data types, then you need to expand your understanding and think in terms of objects, because most of the time we're dealing with objects. Yes, we do get down to primitive data types like name, which is a string, quantity, which is an int, unit price, which is a decimal. We get down to those primitive data types, but a lot of the times we start with these more complex data types, these particular objects. And of course, our objects are instances of our classes, and the classes in these cases of modeling a database represent different database table structures. So think about the data types that you have. And also, as you're thinking about the data types, that means, again, recognizing when you're dealing with a collection and when you're dealing with a single item. So you've got single instances and collections. That's a good question. What happens with group by? We're going to get to grouping in a little bit, but understand that in having our navigation properties that go to collections, I effectively get back that off, get the orange color. I effectively get some natural grouping. So there will be some natural grouping when we have navigational properties, where the data type is a collection. So in other words, when we talk about data, remember data is a customer type. Each customer has many orders. So that's grouping all of the orders that belong to that particular customer. We can do regroupings. We can do our other groupings by using the group by uh, part of link, which we'll look at a bit later. But notice that there are some natural groupings. If you can use the natural groupings, go with that before you start trying to do other groupings. Great question, though. Thank you. So in this example, when we're looking at the subtotal, I've simplified it because I've been ignoring the discount. But I could turn around and maybe have another line item in here or another column. Maybe I'll want to have the maybe I'll want to have another column for the discount. Maybe the total discount, and then I can get the final subtotal. So you're right. You know, I could have made this a little bit more complex. I kept it fairly simple just to start with. Okay. So that's a good question. So you're looking at grouping the same line items to avoid the repetitiveness. That's true. We do have a repetitiveness for the type of the product, but we have different quantities on those particular orders and different prices. So if we try to roll it all up, that would be a much more complex kind of a thing. We may want to do that in some post-processing afterwards. So that's a really good observation that, hey, maybe I want to just have a summary of all of of the average price for the queso cabrales and the average quantity or the total number of items and then the average price. But then again, you know, if you start doing math on averages, you're going to get potentially some wrong calculations, because when you buy 24 at $16.80, you get $403.20. If you buy 50 at 21, you get $1,050. So there's different kinds of considerations to bring into there. Notice, though, as a little bit of a side note, here when I'm saying select new, I'm basically generating what is an anonymous type, but in our program later on, I may want to have that use a concrete type. So I may go and design a class for this shape of the data. And then I can always plug that in afterwards and say new customer summary. Yeah, that's a good point. It's almost like creating a view. Except remember, we're doing all of this in C#. This is still C#. It's going out to the database. It is being translated into SQL in order to get this information. But we're writing it in C# because when we pull this data back from the database, we will have an in-memory object graph. And that's really what we've got here. Is we've got an object graph, a collection of objects, and in each object it has a company name and sales, which is itself a collection of objects. Very good observations. That's another good observation. When we start chaining our queries in LINQ, it is easier than doing joins in SQL. It is a whole lot easier. When you start thinking in LINQ, you kind of have to think in terms of objects and the object graphs that you have. It's a different way of thinking than just these tables that you have to do joining in SQL. In fact, if you read some of the little article stuff on linkpad.net, he talks about that whole aspect of thinking in LINQ rather than thinking in SQL. So there's a little bit of a mental shift you have to go through. And it's also why I really do like emphasizing the fact never use a join when you're working with LINQ. Now, I know that that's a bit of a generalization. There will be a few rare times, but I want to emphasize very rare times when you'll want to use the join keyword, which is part of LINQ. Most of the time, the vast majority of the time, you should never have to worry about that. You've got a natural join. So when we talk about the natural grouping that goes on, what we're really talking about is the whole notion that there are, and maybe what I'll do is I'll just draw it as a single line coming up. I'll figure that out here. Poof. Oh, did that wrong again. Trying to get my lines to show up. So that natural grouping that goes on with our navigational properties, those navigational properties provide us with essentially natural joins. And that's true for all of our navigational properties, is that there are natural joins, whether there's grouping with the property or not. That is, whether we have a collection of items or not. Okay, let me do another quick little screenshot. Let's take another little bit of a look at things. We'll look at product and category names. And I talk about looking at the product and category names as a flat list. So what I'm going to do is I'll just increase the size here. So I start saying I want to look at the product and category names as a flat list. Essentially what that means is I want to be able to start looking at things from the perspective of the products table and the fact that each product has a single category that it belongs to. So that's why I'm starting at the products table, because I want what's called a flat list. Whenever you did SQL queries in database fundamentals, you always got back flat lists. You never got back an object graph, because databases, relational databases storing information in tables, whenever you do your query and you throw in your joins, you're always producing a very flat representation of your data, and you'll see pieces of the data being repeated in certain columns. Wherever you have your one-to-many relationships, you'll see pieces of information being repeated. That's a flat list. Pure two-dimensional. When we work in C# with LINQ, we've been pulling back object graphs, a richer kind of a representation, where we can avoid some of the repetition that goes on and see composition occurring with sometimes collections in those compositions. Okay, so we want to get all of our product and category names. So we're going to be selecting the product name and the category name, but we're going to start from the products table, because that goes to a single instance of the categories. So if you're ever asked for information as a kind of a flat list, this is a way of thinking of it. So a flat list is essentially the notion of I don't want to say a two-dimensional array, but you can think of a flat list as being like a simple table with columns and rows, and there is it is not an object graph of data. So what is that going to look like? Grab that image and a little blur on a few of the other things as well, just because I want you to focus on certain things. So we're going to look at how we get the same information as either a flat list or as an object graph. Let me look at the results of this one. So as a flat list, you can see that I've got all of my products and the category they belong to, but you see the category information is being repeated. This is similar to what you would have gotten from doing an SQL query in SQL Server Management Studio or something like that. That's a flat list. Let's look at the notion and compare it to getting product and category names in an object graph. Here, we're going to start from categories, and you'll notice in our result, what I wind up seeing is the beverage and a collection or another object inside of that. So there's an object inside of each row of my results. The row itself is one kind of an object. So the row itself is one kind of an object. I wanted that in blue. Let's do that. But there's another object inside, in this case, a collection, an IEnumerable of strings. So here's where we've got our object graph. And beverages doesn't have to be repeated because all of these products inside, each of them is a beverage. But I'm starting from a different place in my database table. Instead of starting from the products, each product fell into a single category, or each product belongs to one and only one category. In this case, I can say each category may represent one or more products. And notice, once again, yeah, it's kind of like a group by, but remember, in SQL, even if you did a group by, you would see the information coming out as a flat list, and you'd see beverages being repeated. But notice that when we go and start this out, so from data in categories, data is a category object. So the data type here is a category object. Each category object has many products. The right way to do things is to stay within the context of the object that you began with. This part here from item in products, that would be the wrong way, because if you start with all of the products, you don't have a connection between the product and the category. So definitely you want to avoid doing some jumping back out to the products table. You stay within the category object, and then you get the products that belong to it. And where did my cursor go? Okay, so I will. Let me do it like this. There, check mark. That's the proper way to do it. So think about the kind of result that you want. So we'll stop at this point. When we come back on Friday's class, we're going to look at a couple of new topics. We'll look at sorting the data, and we'll look at the specific group by notion as well. That's what we'll cover on Friday's class. Make some notes about these things. Try them out on your own, and I'll catch you guys later. Have a good day.